Hello everyone, welcome back to my YouTube channel Kodathron. I am Achyutwardhan and today we will be completing our phase 5 challenge, that is including the Resilience4j in Java Spring Boot. In this video we will be talking about all the type of resilience that we can use in our Java Spring Boot, including circuit breaker, rate limiter, time limiter, retries, bulkhead. So we will go step by step talking about all these one by one, and then we will head back to the implementation of the each and every aspect. I'll be teaching you configuration and the auto configuration of Resilience4j in Java Spring Boot. So let's get started. So let's get back to the topic, like why do we need resilience? What is the need of resilience? Now, resilience helps giving up a response of a failure. Okay, what does that mean? Let's say we have some services and each services are connected to each other. If one of the services gets stuck, then it will lead to a cascading failure. What is cascading failure? We have service A, service B, service C. So service B is connected to service A and service C as well. So that means service A and service C can request service B and get response from service. And service A and service C are connected to other services. What if service B gets down? What will happen is service C and other services will get affected. And this is what cascading failure is. Now, what we are trying to do with the resilience is we will give a failure message in order to prevent the timeout of the request. Now, how do we do that? We have different methods in different situations. We have circuit method, we have rate limiter, we have bulkheads. Now, let's go one by one and talk about them in each of them in a different scenario, and at last we will learn about the implementation of them. Now let's talk about the circuit breaker. Now in the circuit breaker, as you are well known with this word, that is it's a circuit, and even if the circuit breaks, it gets open. Okay, so in the circuit breaker we have three states, that is closed state, open state, and half open state. What are these states? Closed states are when all the services, or you can say all the services can request to a specific service if it is not giving a failure, or you can say it is not having a problem. So the request is communicable. What is open state? If the communication is not available between the two services, or you can say the services cannot talk to that service which is at fault. And the third state is half open state. Half open state is a state where if there are hundreds of requests, it will only allow few requests in order to check whether the service is working fine or not. So how they are deciding that the states are open, closed, or half open? Let's go one by one. Let's say at the beginning they have a closed state, means service A and service C can request to service B. There is no problem. But there is a threshold. The thresholds can be put in two ways. Either you can have as a number, let's say 100 requests are there and 60 is the threshold. If this threshold increases, the state will change to open. It means if the 60 requests or above 60 requests are at fault, or it is not given a response, the circuit will come to an open state. Second way is like we can use percentage. Let's say we have 100% and the threshold is around 60%. So the number of requests in a percentage, or you can say an average, if it crosses the threshold, it will come in an open state. Now, when it is an open state, so there are two situations. What it will do? There will be a time duration. Let's say there is a time duration of 25 milliseconds. In 25 millisecond, it will go to an half open state. In half open state, what it will do is that if there are hundreds of requests, it will allow only 20 or 30 requests to go and check whether the service is working or not. If the threshold is not reached, the threshold of fault, or you can say a failure message. If the threshold is around 50, then it will go back to the closed state. It means if the failure rate is less of the service B, then it will go back to the closed state. Otherwise, if the failure rate is above the threshold or the threshold, then it will switch back to open state. This is used when there is a cascading failure problem in services. So let's talk about what is rate limiter. So why do we need rate limiter? As the name suggests, the rate limiter limits the number of requests. Right. Why we need to limit the request? We need to limit the request in order to prevent the DDoS attack or prevent a user to gain a monopoly on the services. Now, in order to ensure that all the resources can be accessed by all the users and we can maintain the stability, we are using a rate limiter. Now, let's go ahead and talk about bulkhead. Why do we need bulkhead and how is it used? Now, why we need bulkhead? Now we need bulkhead in order to limit the number of concurrent execution. Now what does this mean, number of concurrent execution? Let's move back to the web and I'll explain you with the help of diagram how all these this facts work. Now let's say when we are talking about bulkhead, we know that each services runs on a thread, and we also know that there is a limited number of threads in our system. Now, for a scenario, let's understand how threads and services work. Let's say that we have a service A. For a service A, the thread 1 is assigned, and once the work is done, the service A ends and the thread is freed. Now, in this scenario, you can understand that there are 200 thread pools and there are a lot of services running. Now, as you can see, with the services A and all the other services are running good, what they will do is they will be assigned a thread, and once the execution is done, the threads are freed. This is the normal working condition. Now, what happens is when the service A is at fault. When the service A is at fault, what it will do is it will start occupying all the threads. So let's say the service A, first called service A is blocked. The thread is blocked. The second thread is blocked. Now the another thread is also blocked. So by doing this, all the threads, or you can say, are occupied. Once they all the threads are occupied, there are no other threads where other services can use, and this could lead to a state where all the services will get stuck and all the threads will be get stuck and no other services can run or execute. Now, in order to prevent this issue, what we are going to do is we need to fix the number of threads for each service. Let's talk about this. Let's say there is a service A, service B, service C, and service D. Now each services has been given only number of threads. Let's say we have given max thread of 3, and once a user requests a service, let's say the service A is given a thread. So what happened is, like, the first thread is given to service A, and then there is another request, then there will be another thread assigned to service A, and while the threads are being assigned to a service, the count will also get increasing. So in this diagram, as you can see, there are already 3 services, so the count will become here 3. Let's mark it 3. Now once the count is 3, so what will happen is if there is another request for the service A, this won't execute because the count will be greater than the max. So if the count is greater than the max, it will do, it will call a fallback function. Yes, it will call a fallback function. Now what is this fallback function? This is a fallback. This is a situation when no other threads can be assigned to the services which are at fault or it is taking time. So it will call up a fallback function in order to give a failure message, or you can say which will help us to avoid a timeout, and also which will help us that not all the threads are occupied by a certain services. So this is how the bulkhead works. So in order to work with bulkheads, we need to remember we need to have maximum number of threads assigned to all the services. If the count increases or are more than the max, the fallback function will be called. So yes, this is how the bulkhead works. Now let's go to another topic, that is retry. Now, retry is actually helps us in managing the retry for the failure operations. Now, all the other above operations, which is circuit breaker, rate limiter, or bulkhead, retry helps us in order to try whether the operations can be carried out or not. So now this I've given a brief introduction to all these topics. Now we will move ahead for the implementation part, how these things are implemented by using configuration like custom configuration, or by using the uh, auto configuration. And one more thing, we will also be looking how the cloud security provides us the rate limiter. Now, before moving to the implementation, let me show you some documentation where you can go through and have a knowledge about the Resilience4j, how it is being implemented. You can read the documentation and carry out in your project. So let's go to the web and let me show you which all parts, which all documentation you need to refer to. First documentation is you just need to go to this Resilience4j website, and in the Resilience4j website you need to go to the get started. Now, once you go to the get started, here on the left, you can see here are the core modules where they talk about the circuit breakers and how they are being implemented. You can also refer to the example part where you can create the custom circuit breakers with the custom of your own needs, with your own needs, and then you need to have a registry. By using this registry, now you can use it on any methods, and you can refer to these examples for all other modules like bulkhead, rate limiter, retries, and others. And on the down part, you can also refer to the Spring Boot 2 and 3, where you can see how the Spring Boots are implemented on the Spring Boot as well. And also, if you are using Fang, so you can have you can go to this add-on modules and you can refer to how to use the resilience with the fan. Now, what is fan? As you know, fan helps us in the direct conversation between the microservices. First documentation is this, and the second documentation is this. Tech tutorials. I will share you the links in the below description where you can just look at how the circuit breakers are implemented. It is well explained documentation, which all dependencies you need. So, yeah, there are two ways in order to implement. Either you can use this YML wala part, or the different, you can just have your own custom configuration. So let's move ahead to the documentation part. And now here you can see that first thing which we will be talking about is the using the auto configuration. Now the dependency would be like Spring Cloud Starter, Circuit Breaker, Reactor, Resilience4j. Okay, this dependency you can avail it from the Maven repository. Okay, now we need to go to the configuration. Now in the configuration part, what you need to do, you need to add it in your application.yml, which is present here in your resources. Let me show you. It is present here in the resources, and then here you need to add it. If you have this, you can add it here, or if you have the configuration server or your config repo, you can add it here. Now, once you have added it, you need to add these configuration, that is Resilience4j circuit breaker configs. Configuration is default. And then all the sliding window size, minimum number of calls, failure rate threshold, all of these should have your custom values. Now here in the last part, you need to add which type of sliding window you need, window type you need. Now for this, you can refer to the documentation. You need to go to the circuit breaker. In the circuit breaker, we have two types of sliding windows. First is the count-based sliding windows, and second is the time-based sliding windows. You just need to add it here. Now also you need to add the instances. Without these instances, you cannot use the circuit breaker. Now what is this product service config breaker? This is just a name. Okay. Now in the which type of instances? Like this is a name, product service circuit breaker. Base config is default. I'll tell you what it is, and in the ongoing videos. So let's focus here. Then the failure rate threshold, I have put it as 50. Now remember, there are two types. Either you can do it as in count based, or you can also refer it to as in percentage. Here also I've introduced the time limiter, where the time of duration will be 3 seconds. Otherwise it will be canceling. Okay. So both the instances will be used with this product service circuit breaker. Now in the application gateway config Java, what you need to do is, let's go to the file first. Inside the config file, in order to use this the circuit breaker, you need to refer this wall up this part. What we have done is, we have this route where the route is pointing to the product model. In the product model, we need to give the path. Now, while we give the path, we need to use the filters. Now, while we are using the filters, we need to specify which type of filter we need. So we are using the circuit breaker. Now, as you now further on, when we see that we need to set a name to the instance. Now, this instance name, as you remember, we have used here. This is the instance name. This is how they will refer it. Now, secondly, you need to have this uh, fallback URI, where you need to, if the circuit is open, then it will fall back to this URL, or you can see this specific path, and share the request. Okay, failed message. Now, this is how the circuit breaker is being implemented on the route part itself, or you can say when the clients are requesting for the product model. If it fails, directly it will call to the fallback function, and this is and accordingly you can use other services like rate limiter or other things. This is what just one example how it is being used. Now in the pom.xml, don't forget to add these dependency. Okay. Now in the next scenario, we will see about the rate limiter. Now the rate limiter is being provided by the cloud gateway itself, where we are using the Redis rate limiter. Now we will see how to use them. Similarly, we don't need to have any type of dependency. Normal dependency will also work, which are like dependencies such as the Spring Cloud Starter Bootstraps. So what we need to do is that, it is similar to what we have done here. We don't need to provide any YML values or something. We just need to have two to three things. First thing, which we need to have this key resolver. Why we need this key resolver? This key resolver tells us the IP address of the user, which will help us to block the particular IP address in accessing the module. We will also see how this is worked by usually running a script which I have made in order to just check whether it is working or not. So yes, now what we need to do is, like, we need to have this path. Now, after giving the path, the things we need to add is this filter. Inside the filter, we need to give this request rate limiter. As you can see in this filter, we have a lambda expression. We have this this arrow function is called the lambda expression. As you can see, we have above as well. This tells us that this function is a functional interface which will have only one method. Now, what we are doing inside it, that in this request rate limiter, we need to provide two to three things. Like we need to have this set rate limiter. Now, this is a Redis rate limiter which we need to provide it as a beam. Either you can write here only. I have created a separate file for this where we have just created the configuration with a beam which is Redis rate limiter where we have returned the default replenish rate and default burst capacity. The replenish rate tells us the number of token or the request per second, and the burst capacity tells us about the maximum number of tokens that can be stored at once. What we have set is this set rate limiter. I have already told you about this Redis rate limiter. We need to have the object of this Redis rate limiter. Now, secondly, we need to pass on this key resolver. As I told you, we need to also have the object of this key resolver. Now, this key resolver tells us about the IP address. Now that we have this set deny empty key is as false. Yes. Now, after providing these three things, the function will be good to go. And if the user tries to make more than the five requests, then it will lead to 429 status. That tells us that you need to wait or that is blocked. Right. Now this is how the Redis rate limiters helps us, or otherwise you can use the rate limiter of the Resilience4j. Now we will walk through how we can use uh, without Spring Auto configuration. What does that mean? That how we can use the custom configuration. Now, in order to work on custom configuration, we need to have few dependencies. One of the dependencies is this Resilience4j circuit breaker, or you can use Resilience4j all if you need all types of modules, if you are using all types of modules in your project. Otherwise, you can prefer using a specific module if you are using circuit breaker or other module. In this example, we will just talk about circuit breaker, how it is being implemented, and how we are using this custom um, configuration. So for this example, we will go to the cart model. What we have done is that let's go through first. So we'll go to the services for a part. In the services, we will see where we have implemented it. Now, as you can see, we have implemented into add to cart. Now we know that persons or the users, whatever products they like, they store it in their cart. So what we have done is we have whenever the user is adding an item from a cart, the product will not be fetched from the UI, it will be fetched from the product service itself. Now, beforehand, we were using the Fein client in order to communicate between the microservices, but here we will be using the Resilience4j, where we will connect the Resilience4j with the Fein client, and then we will be calling out the method. So for this, what we need to do is we need to have certain configurations. Now, in first hand, we are going to create a circuit breaker config. Now, in the circuit breaker config, we have few things. Like first of all, what we have done is we have created a circuit breaker config class. Now, once we have created class, we need to create some beans. Now, what in the beans we need to do? Now, at beforehand, what I told you is like in order to use the custom configuration, what you need to do is you need to give values use in the configurations. So, what the similar things we have done is like we have taken the circuit breaker config and then we have provided all types of values we need accordingly. So you can see sliding window type is count based, and then the similar thing which we have done in YML. Then the minimum number of calls is 5, failure threshold is 50%, and then waiting duration is 10 seconds, and similar all the all the values I have called. Now, once the values have been given, I just done a dot build. While giving this dot build, this circuit breaker custom configuration will be created. And once the configuration is created, we need to mark it in registry. Now, once you have marked it, how we will mark it is that return circuit breaker registry dot of config. Once you have made this configuration, you need to register it. That's simple. Now, in order to register, you need to create a beam of the circuit breaker where you will have a name as product service circuit breaker. Now, it sounds similar as the instance, right? Yes, this is an instance only. This is an instance only where we have product service circuit breaker. Now in this product service circuit breaker, we have this registry where registry will be done in the name of product model. In which model we will have? This is in product model. This is simple as of what we are doing here. Now what we will do is we will move ahead what we have to do in the service part. This is the configuration. Now move what we will do, we will create a file name called product service.java, which will help us to link the Fein client with the with your circuit breaker custom configuration. In the in the Fein file, you don't need to do anything. It's just similar how you manage your Fein client. It's similar. We don't need to don't need to change anything. We just need to create a product service.java. What we have to do in the product service.java, we have auto wired the product client, means we have created the like we have called the object of the product client. Now we have some another auto wiring. What we have auto wired is this product service circuit breaker. We have also given a qualifier in order to uh, prevent the ambiguity of the services, or we need to refer to, like, ambiguity is means like we have two beans of the same name. In order to remove that confusion, we need to have this qualifier as product service circuit breaker. This will refer to this one. Okay, now what we need to do is we need to have this product d2 as the return type. Now once it is just similar to what we have done in the Fein client. As you can see in the Fein client, what we are doing, we are receiving this product d2o. In this product d2o, this method, what we are concerned with, we need to pass this uuid product id, and then it will return us the product d2o. Similarly, what we have done in the product services, that we are returning the product d2o and we are getting this product by the product id, and the uuid is passed. Now we need to have a supplier where we need to decorate it. Okay, now in the supplier type, we need to give this product d2. Whatever the return type is, we need to give it in the supplier. Without this, it will give us an error. Now in the decorator supplier type, we have circuit breaker dot decorator supplier. Now in the decorator supplier, what we need to give is this product service circuit breaker, where we will have a lambda function. In this lambda function will return us the value, whichever value we get it from the Fein client. So this value is returned it from the Fein client. So after this Fein client, we get a value. If we get a value, then it's good. It will return it from the supplier, try of the supplier. Otherwise, it will throw the fallback function. As we know, we have fallback function for each module, for the circuit breaker, for the bulkhead. So similar kind of, we have a fallback function where we will give this default values. We don't if we get an error, or if there is a fault on the service. So how we will implement this? This is how we have to do the product service wala part, where we have just connected the Fein client with the circuit breaker custom configuration. Now what we need to do is we don't need to connect the card service directly to the Fein client. What we will do is that we will call the product service which we have made here. We will directly call the product service and give the UUID. And once it is received, so it will work accordingly how the circuit breaker works. It will work on the custom configuration which we have provided here in the circuit breaker module. Remember, Resilience 4j is specifically used for working on the methods of the microservices or a certain microservices. It is not really recommended to directly use it on the API gateway. As in POC, I have done it in the API gateway, but it is not recommended. It is recommended to use it on the microservices if the microservices are talking to each other. So let's get started with the running up the scripts and checking whether our rate limiter or the circuit breakers are working with the microservices and on the API gateway. First of all, we will run the script for the rate limiter. As on the right side, as you can see, on the right side, we have a script running the auth login. Here we will test our rate limiter whether it is actually working or not. So yes, let's start with running the script. Now once I press enter in order to run the script, you need to just type dot slash in the name of the script. Now once I run the script, as you can see, we have total of 40 calls. Now in the 40 calls, you can see that on the above first 1 to 10 are running. I hope. Let's go up. Let's go up. Yes, up to 10 are running, and after that, we get a message of 429, as you can see here. This is 400 because I haven't passed any of the values for login. And in the logs also, you can check we have an error called like there is no invalid UUID string. So that's why there is a 400 error. So now let's check for the circuit breaker. So as you can see, we have the script where I have the bearer token from beforehand only, and then we are going to add the quantity. Now this is the script. When we click enter, here you can see the quantity is added is 70, and we will get the response. So we have the response. Now what we'll do is, now as many time as you want, we will get the response. Now what we'll do is we will stop running the product model. This is how we create a faulty service. Now what we'll do is we'll request as many time. See, for the first time we got the quantity 0 and the product is out of stock, and this is a default value. So what we'll do is we'll do it several times so that we will surpass the threshold. Once we surpass the threshold, now what we will do is we'll run the uh, product model. Now let's see what now is it is in open state. Okay. Now once it is in open state, what we'll do is now we will again run the same script. Let's see what we get. Now once we run the script at the below, let me clear it first. Now once we do it, now the quantity is still 0 even though the product model is up. Again, you can see now once it is in the open state, it will go after some time on the half open. Once it finds that the call is correct, like the server is started working, then it will start adding the quantity. This is how now this is how the things are working. Now, I hope you liked my video. I hope you liked my explanation. I hope all things are clear out on your mind and the implementation. On furthermore, we will work on the deployment on the next video. So please press the bell icon, hit the subscribe button if you like my explanation. And for furthermore, more videos, what type of content do you want after this production ready Java Spring Boot playlist? Which type of video you want? Just comment down in the comment section. I will refer it and I will make video on those type of videos. Thank you guys. I hope you liked my video again. Bye bye.